going to talk about balancing oxidation reduction equations. Okay, before we talk about this, I am sure you understood the previous class, and in case you have never listened to it, it's important you go through the previous class. Okay, the previous class was important as it was the introduction to oxidation and reduction. Okay, where we were able to explain what is oxidation and what is reduction. Okay, we were able to understand what these two terms are in terms of oxygen, in terms of hydrogen, in terms of electrons, and in terms of the oxidation numbers. Okay, we stated that in terms of oxygen, oxidation is addition of oxygen, while reduction is removal of oxygen. In terms of hydrogen, we stated that reduction is addition of hydrogen, while oxidation is removal of hydrogen. Okay. In terms of electron, we said that oxidation is loss of electron, that is oil, O-I-L, oil, loss of electron. Okay. Then reduction is gain of electron, that is real gain. So reduction is gain, okay, of electron. Then in terms of oxidation numbers, we stated that oxidations, in oxidation there is increase in oxidation number. For reduction there is decrease in oxidation numbers. Okay. Then from there we're able to identify which one is reducing agent and which one will be oxidizing agent. Okay. We stated categorically that for reducing agents, that is substance that is being oxidized, and that means that is where oxidation takes place. Okay. For oxidizing agent, substance that is being reduced, and that means that's where reduction takes place. Are we together? We also gave examples of reducing agent and oxidizing agent. Okay. Some of your antiseptics, your disinfectants, antibacterials, we say all these are examples of oxidizing agent. Hydrogen as an example of reducing agent. Okay. Coke, okay, as a substance from carbon is an example of reducing agents. So that is a recap of the previous class. So today, before we move on, I would like to let you know that by the end of this class, okay, you as a student, you should be able to write oxidation half reactions. You should be able to also write reduction half reaction. Okay, and then you must be able to solve examples on balancing redox equation. Okay, are we together? So let's get down to class. Okay, so half reactions method for balancing oxidation reduction equation. So there are powerful steps that I want you to understand. I'll play around through while we move to the examples in details. Okay, so number one, you must separate the equation into two half reactions, and then you write down the two half reactions. Okay, one is oxidation half, the other one is reduction half. Okay, so the next thing you do is that you balance each of the half reactions. They must be balanced. Okay, then how do you do that? You balance them by first balance all elements other than hydrogens and oxygen. So any other elements involved, you balance them first. Okay, after that is balanced, then you balance the oxygen by adding water. Okay, so meaning that where we have oxygen related, you are going to add water there. Are we together? Good. And then you balance hydrogen by adding hydrogen ions. Okay, if that is an acidic solution. Are we together? And by implication, it means that if where you have oxygen, you add water, so of course the other side you are going to add hydrogen ions. Are we following? Good. Then you finish that by balancing the charge. Okay, and how do you do that? you add appropriate numbers of electrons. Okay, good. So after that, you have to now multiply each of these half cell reactions so that you make the numbers of electrons equal. Are we together? You must equalize the numbers of electrons. After that, you add the two half equations. Okay, add it up and simplify. What do we mean by simplify? You balance them, and you will see that electron may cancel, other may be deducted. Okay, so and you will now check. Finally, you see that it's balanced. Are we together? So let's move to before we have an example, a quick review of what you know from the previous class. Oxidation is loss of what? Electron, right? And also you have been told that increase in oxidation number is also oxidation, right? Example, you can see that zinc, okay, lost 2 electrons. Are we together? Has become oxidized. Are we together? And that means we also have the oxidation number increasing from 0 to what? To 2. That is oxidation. Good. Then reduction, acceptance of gain or gain of electron, right? Good. Very good. And that is decrease in oxidation number. Are we following? Good. So this is 0 and then this is -1. There is decrease. Yes, yes or yes. Very good. So let's move on to a very good example. So we have this and we want to know there are half reactions. So what would it be? Okay, so the first one is checking this. Actually, you can see that this is +2, okay, and this is what? +4, okay. What that means is that this has lost 2 electrons, and what does that imply? Loss of electron, that is oxidation. Or in another cell, this guy +2 +4, that is increase, that is oxidation. So this becomes a half cell equation for oxidation. Are we together? Good. Then check, okay, this, when you check that, there is decrease, right? Good. There is decrease of the numbers of electrons. There is decrease. There's what? Decrease. So this automatically becomes our what? Okay, so please pardon us. This guy is +2, please. Okay, and this is 2 plus. Okay, so this is 2 plus. Good. So this is our reduction. Are we together? Good. So oxidation half cells electrons are products, and you should take note also. That is another insight you should understand. And then reduction half cell, that is oxidation. Okay, I've told us already. And a reduction half reaction, electrons are reactant, and that is that. Okay, I've also told us. So let's move on to the next thing, and that is sorry, please. The next thing is example, and let's talk about that briefly. So here we want to talk about how do we balance these equations. Okay, how do we what? Balance these equations. So take notes. The first thing, we have to write the half cells first, right? Go. So now this, who can tell us what this half equation will be? Okay, so you can tell yourself wherever you are. Are we together? But something is very important. Chromium, okay, was having oxygen, but now no oxygen. So in terms of oxygen, this is a removal of oxygen. So that means this is what? Removal of oxygen is what? That means is reduction. Are we together? Reduction. So let's move on quickly. Reduction. Very good. Okay. So the next is what? There's an addition of oxygen, and that is oxidation. Very good. Good. So you write the first steps. So the second step, balance the both have reactions for all atoms except for oxygen and hydrogen. Remember. So here is the atom is 2, so that's why we have to introduce the 2 here, so that as to balance it. Are we together? Good. So that is balance for our reduction. So let's check our oxidation. So I think it's balanced, right? For the iodine is balanced. So let's move on. After that, you are now going to ensure that you balance each half reaction by adding water to where there is oxygen, and then hydrogen ions to where we have other elements, okay, or charge. Are we together? So good. So that means from the reduction, okay, we are going to, we're going to add water to, please pardon me please, we balance this by adding for O by adding water to where we don't have oxygen, please. That is the appropriate explanation. And then you add hydrogen ion, okay, to where we have oxygen. So meaning that here we are going to add water, okay, and here we will add what? Hydrogen. Remember, we are in reduction, okay. So when we do that, we must ensure that it's also balanced appropriately, right? Good. So let's do that. So balancing it for hydrogen, okay, this has to be, okay, since it's water, right? And okay, let's say the first thing we do is adding just hydrogen and just water molecule, okay. So in balancing it, of course, if you add 2 here, you have 4. Are we together? So you are going to have 4 here. So but remember that if you add 4 here, so that means oxygen will be 4, and the number of oxygen you have is 7, and the atoms of oxygen, please, is 7. So the best is to get 7, and when you add 7, so oxygen carries 7, and the total for the hydrogen becomes 14, and that's why we have to introduce 14 to this side. Okay, are we together? Very good. So that is balanced. Good. So the next is that. So remember, we are adding water molecules to where we don't have oxygen, and we are adding hydrogen to where we have oxygen, right? Hydrogen ions. Very good. So when we do that, we're also going to balance that. So H2O like this initially, okay, that's what we had, and initially we also added hydrogen and hydrogen plus, please, okay, hydrogen plus. So when we do that, we discover that here water will be, oxygen needs to be 3, right? Why? Because if you check, this is 3 already, right? So this guy is 3, so we need to make it, and the only thing we should do is by introducing 3. Are we together? So when we introduce 3, so automatically oxygen is balanced, then hydrogen becomes 6, so we need to introduce 6 to this place. Are we together? Meanwhile, for the iodine is balanced. Good. So it means it's balanced now. Are we together? So the next step is that you should balance each half reaction for charge by adding electrons to the side with greater positive charge. So what are we saying? Good. Where we have positive charge that is the greatest is the left hand side. Okay, so introduce electron. Okay, when you introduce an electron to this side, okay, of course we have to balance it. How do we come about 6? Okay, how do we come about 6 electrons? How? Okay, now 6 plus 14, what is that? Okay, that is 14 minus 6. Are we together? 14 minus 6 minus 2. So that means we have 6, right? Good. So we have 6 all together, and then this is also 6, which means it's balanced. 6 plus 0, which is balanced, right? Very good. Good. So that's why it's 6. Okay, that's why it's 6, because we have 14. This 14 we multiply this, that is 14, and then this one is 1 multiplied by this, that is minus 2. Are we together? So for that to be able to balance, we already have 6 here. Okay, 2 times this is plus 6 already. So to make it 6, so the only thing we could do is to add 6. Okay, 6 electron. Very good. So the next is for our oxidation. So the next thing also, we are going to introduce electrons to where we have the greatest charge. So where we have the greatest charge by oxidation is the right hand side, because we have 6 plus 1, and that is 6 times 1, that is plus 6, and then minus 1, that is what? Plus 5. This is minus 1, so you cannot. So we have plus 5 and we have minus 1. So it means we have to have minus 1 here. Are we together? So that both here can be minus 1 and here can also be what? Minus 1. So meanwhile we have minus 1 plus 6. That is what? Plus 5. So we need to introduce plus 6 electron. That means we have plus 5 minus 6. Then we have minus 1, which is balance. Okay, so electrons balance, and every other thing is balance. Very good. So the next thing is to multiply each of them by a factor, so that's to make the electron the same. But I think we have them, they are same already, so no problem, they are same. So assume that this is 4 and this is 2, for example. So what we do is we must make this electron to be equal. That's what we mean by multiplying. But since the electrons are the same, so the next we move on to the next step, and that is adding up. Okay, add the two balanced half reactions together, so that electrons can cancel and some other same species can cancel out. Okay, very good. So this is reduction, okay, plus oxidation. So what that means is that the whole of this, okay, the whole of this plus the whole of this, and then the whole of this plus the whole of this. Are we together? Good. When we do that, you can see that this is what we are going to have. So this guy plus this plus water, 3 molecules of water, and then plus this also will be equal to this guy plus this, okay, plus this plus this. Are we together? Now when we do that, you can see that 6 electron is appearing on both sides, so it's going to cancel out. So this electron will cancel out because they are equal. Okay, and that is the essence of multiplication in the first place. You must make them to be equal. Okay, now then we have the numbers of hydrogen ions. This is 14 and this is 6. So subtract it, then you are going to end up having what? Subtract 6 from both sides. So here becomes, this one will cancel out. Then you have 14 minus 6, and that is 8. That's why we have 8 left, and then 8, okay, plus this, okay, plus this. Are we together? Then water also the same thing. Okay, the same thing with water also. So you bring this guy to this guy. So subtract 3 molecules of water from both sides. Okay, so when we do that, you have here we'll be left with 4. That's why. So you can see. So this is the balance equation now. I am sure you have followed the class.